cryostat. So we need cryostat to study something in low temperature. And liquid nitrogen is commonly used to cool down things. However, it is really, really cold. So it's 321 Fahrenheit. It's really, really cold. So it can only be stored in a highly pressurized cylinders. In order to keep it as a liquid, we need to pay attention to the low temperature and the high pressure safety. So this is a very stupid behavior. But you will ask, why does somebody do this? Actually, this is not unusual. Let's say you have an open door, and you pour liquid nitrogen into it, and then you do something on top of it, and then you just drop something into it. And then you happen to think about it, you just try to grab it. That's what will happen. So this is a common mistake. Just do something right on top of it, open the door, and drop it, and try to grab it. So this is the consequence. And also, it may get exploded. Why would this happen? This is actually also very common because you have a liquid nitrogen cylinder. Just try to get some liquid nitrogen from, for example, from a nitrogen generator in our chemistry department, and then you want to move it here. So on the way, there is a kink. Your cylinder cannot get through it. What do? Push it, and then you just fell down. Bomb. That's the consequence. It's a very common mistake. So just pay attention. It's very dangerous. But if you use it safely, it can help you a lot. We use liquid nitrogen to make ice cream. It's very delicious.
Is it so?
Yeah. And then sometimes you use a vacuum for insulation because you want to do something in low temperature, in a room temperature environment. So you need to vacuum for insulation. And then you need feed-throughs to bring electricities, like or signals, gas, and the light in and out of your chamber, vacuum chamber. And it seals between the interfaces. So here I have some examples. So this is a part of the vacuum chamber, and then this is a gas feed-through. So we need to connect these two, and then in between, this is called interface in my definition, and then you need to seal this part. So this is called a flange. Typically there are two types of flanges. One is called Ka flange, the other is called Cf flange. And the Ka flange, so the basic concept for flange is that you have two parts, your chamber and your feed-through, and then there will be a gasket in between. So to seal it. For the Ka, the gasket is made of plastic, or we call it O-ring. It's a black thing here. And then because it's made of rubber, then you cannot use it under the room temperature. It cannot hold high pressure. However, it is very easy to assemble. You just use this clamp. That's it. It's very simple. While for Cf flange, we use the metal gasket here, and it can be baked. That means it can be heat up to a high temperature. It can also be used at low temperature. It can hold very high pressure, but it's very hard to assemble. In order to assemble this one, you need to put a lot of screws here and tighten them. So we are going to use Cf flange a lot. Here is how do you assemble a Cf flange. The basic thing here is that at first you need to go into the clean room and wear gloves because this is a vacuum chamber. If you introduce all kind of dust here, then you cannot reach high vacuum. You may also destroy your vacuum pump. And then here shows you how can we reach seal. So this is a gasket. It's normally made of very soft copper. And then in the flange here, you may see it later, there is a blade in each side of the flange. Then if you press this two, blade will get into bite into the gasket. This is how you seal the whole thing. Then here you're going to see there is a small groove each side. You should put them together when you tighten the screws first. This is used to test the leakage of the whole chamber. So let's say you have a huge chamber down here, and you know where is the leak. So normally you use some leak test gas. Normally it's helium. And just spray some helium here and see if you can test if you can helium in the leakage detector. And this way you can know which part of the chamber has the leak. So put them together. And then when you tighten the screws, you need to follow this sequence. So don't tighten the screws on one side first and tighten the screws on the other side first. This will create an unbalanced the pressure to the gasket. So if you open the chamber, you'll see that the gasket is not evenly pressed. And then we have chambers, we have pipes, we have tubes. We need to connect these two together. So to connect to the chamber, we have these flanges, CF flange or K flange. While for the tube side, we have also two standards, the swage lock and the VCR standard. So VCR is for ultra high vacuum. So we are going to use this a lot. However, swage lock is very convenient, so we will also use it in other applications. So for the swage lock, basically you will have a tube, and then in the tube you have two ferrules, and then you just tighten them with wrenches. Here, for the VCR, you have the VCR is very similar to the CF flange. You have a gasket in between, and then just tighten these two parts together. Press the gasket. So here I show you a plot of swage lock fitting assembly. So basically, at first you put these screws on the male part, and then you put your pipes into it, and then you start to tighten it. And then after you tighten it, you should use a spacer to check the space between the two screws, and to keep. If you tighten too much, and then next time you can hardly open it, or even if you open it, you cannot use it again. So there is a dedicated space checker for you to check the space between the screws. And then you have special tools to bend the pipes and to cut the pipes. So this is a typical pipe here. And then to cut it, you have this. So you have this rotating blade here. Then you have this part to press the pipe. So let's say put your pipe in between here, and then just rotate it. Once you rotate one round, tighten this to give some pressure and rotate it again. And after several rotations, you will be cut into two. To bend it, we also have a special tool that is shown here. So you have your pipe going through one of this, and then you just bend it. So there is a degree here. Normally you want to bend it to any degree. Go like this. Or you can bend it to any degree you want. going to give you more instruction when you really start to do something.